Okay, I'm going to try this on the smart board today because these problems are a little bit longer. This is 3, 5. We're going to solve by elimination. 3 equations with 3 variables. So we're actually looking for the ordered triple, the x comma y comma z, that is going to make this work. So it's actually only the first step of the problem and the last step of the problem that is actually new. What you want to do first is you want to eliminate one of the variables, and you have to do this twice. So looking at the problem, I'm just going to go x's, right? So I'm going to take these first 2 equations. Since they have opposite x's, I'm going to add them together and get rid of my x's. So negative 5x and 5x is gone. Y and 3y would be 4y. Negative 2z and negative z is negative 3z. And 2 and negative 19 is negative 17. Then I have to pick 2 different equations to do the same thing. So I'm actually going to pick the first one and the third one. And to get opposite x's, I'm going to have to multiply that third one by 5. So the first equation is saying negative 5x plus y minus 2z equals 2. Multiplying that last equation by 5, we get 5x plus 10y minus plus 20z equals 30. So when I add these 2 together, my x's cancel out. I've got y and 10y is 11y. Negative 2z and 20z is positive 18z. And 2 and 30 is 32. All right. So now what I do is I'm going to use these 2 equations as my system. So that is the first step. That's the new step, right? Get rid of one of the variables twice. Get rid of one of the variables twice. So now I can see I'm using my new system here. So I have 4y, I'm just going to rewrite it to make it pretty, minus 3z equals negative 17, and 11y plus 18z equals 32. So you can ignore everything else and just look at this system I just wrote in black. That is like the 2 equation system that we were doing in Algebra 1. So I can just focus here for now. So I'm going to go for the z's. I have 18. The opposite of 18 would be negative 18. So I'm going to multiply the negative 3 by 6. So let's see. 6 times 4y is 24y. 6 times negative 3z is negative 18z equals 6 times negative 17. I'm going to double check that in my calculator file. 6 times negative 17, negative 102. So now I'm going to add these 2 together. The z's cancel out. 11y and 24y is 35y. 32 and negative 102 is negative 70. So then negative 70 divided by 5 gives me y is negative 2. All right, so just sticking with that same thing, I would then plug the y back in to find z. So I'm going to go with the green one here. So I'm doing 4 times y is negative 2 minus 3z equals negative 17. So I got what? Negative 8 minus 3z equals negative 17. So when I take the negative 17 and I add 8, now I'm looking at negative 3z equals negative 9. So when I divide by negative 3, I find out that z is 3. All right? So this entire middle part is review, right? You've been doing that. The first part was new. You had to get rid of one of the variables twice to make your system. Now the last step is new. Now that we have y and we have z, we can pick one of our original equations, plug them in, and find x. So let's see here. I'm going to go with this bottom one. Just looks easiest to me. So I take x plus 2 times, now I know that y is negative 2. Plus 4 times, now I know that z is 3 equals 6. So I'm going to simplify. So I have x minus 4 plus 12 equals 6. Combine like terms, x plus 8 equals 6. I subtract 8 and I get negative 2. So then my ordered triple answer here would be x is negative 2, y is negative 2, and z is 3. there's your ordered triple answer. So this is the x comma y comma z that would work for all three of those equations. All right, we're going to try one more here in the notes. So let's look here at number 2. All right, so let's go over here to number 2. So we're done with number 1 for now. Actually, I'm just going to cross it off. Don't even think about it. So first step is the new step. Take 2 equations and get rid of one of the variables. This time, I'm actually going to go for the z's, because looking at my z's, I can see I have opposite z's. So if I go with the second and the third equation, I can see the z's are already opposite. When I add them up, I get negative 4x plus 5y. Z's cancel. Negative 3 and negative 9 is negative 12. Then I'm actually going to use the first and third equations, because looking at those, I can see again that the z's are opposite. So adding the first and third together, x and negative 2x would be negative 1x. Negative 2y and 4y is positive 2y. Z and negative z cancels. 6 and negative 9 is negative 3. So that's that first new step. Now I've got my system of 2 equations with 2 variables, just like Algebra 1. So I don't have opposites. I'm going to go for x's. They look better. So the opposite of negative 4 is positive 4. So I'm going to multiply that bottom equation by negative 4. So the top red one would say negative 4x plus 5y equals negative 12. Multiplying the bottom one by negative 4. Negative 4 times negative 1 is positive 4x. Negative 4 times 2y is negative 8y. And negative 4 times negative 3 is positive 12. So now I can add them up. My x's cancel. 5y and negative 8y is negative 3y. Negative 12 and 12 is 0. Nice. So y is going to be 0. Now knowing that y is 0, I can go back and plug it into either my red or green here. Oh, I'm going to go green, right? So I have negative. So I'm taking my y equals 0, plugging it into my green. So I have negative x plus 2 times 0 is y equals negative 3. So I really have negative x equals negative 3. So x is 3. Now, the last step, which is the other new step, now that I know 2 of the values, I would go back and pick an equation that has 3 variables. So I'm going to go, I don't know, with the top one. So we have x minus 2y plus z equals 6, just rewriting it so you can see it. So I'm substituting in x is 3 minus 2 times y is 0 plus z equals 6. So I'm really at 3 plus z equals 6. So when I subtract 3, I find out that z is 3. So then I would just write my answer as an ordered triple, x comma y comma z, that works for these 3. X is 3, y is 0, and z is 3. So my answer is 303. And that is how you solve a system of 3 equations with 3 variables using the elimination method.